Everyone, am I audible? Yes. Yeah, guys, am I audible? Yes, sir. Okay. Cool. Hello, Saad. Is it your first class?
Yes, sir.
Um, I have prior information about this. So, have you attended any of the class? I mean, any of my class, or you were attending any other class in the Learnivio itself? Or is it like your first class only?
No, sir. I was attending Akshay sir's class.
Okay, okay, okay. And what have you done in, I mean, what chapters have you completed in that class?
Matrices, and we were doing determinants. No, we finished determinants. We were doing relations and functions.
Okay, so we are also doing relations and functions, and we have completed many one and one functions. So today's class will be. So have you like gone through any of the lectures from relations and functions, or like
No, sir.
you have started? Okay, good. So in that case, Saad, I don't think you will be able to understand much in today's class because we are already doing this on, and we are on fourth or I guess fifth class.
Oh,
Most probably we'll finish it today, relation and function. But yeah, we can have extra lectures if you want, or maybe we can adjust you in some other class also. So, but the chapter will be completed. Don't worry about that. But today's class won't be much beneficial for you. But you can join this class and have an idea like how the class goes and everything about the process.
okay, sir.
Yeah, and for everyone else, we have discussed this, how to find out range of a function, and we have discussed four questions from that. So, and I have given you this question, fx is equals to root over x square minus 1 as your homework. So, can you tell me the answer for this? Has anybody solved this? Whatever is your answer, just share it. I mean, if you haven't solved this question, then I would like to start from this question only because we have given this your homework, and I would like to know whether you have understood how to find out range of these kind of functions or not. Please start, everyone, barring Saad, obviously. So the question is, fx is equals to root over x square minus 1. We have to find out the range of this function. And in this case, the value of x would be, we should write the value of x as well because all the real numbers we cannot give it all the real numbers. So here x would be either minus infinity to minus 1 union 1 to infinity. After this, we can directly reach to the main question, which will be solved with the help of many one. And Shahid, I think that is incorrect. Shahid or Shahiz? Oh, Shahid. Yeah. Shahid, that is incorrect. Please check it once more. Austin, Faiza, Mahmudin, Madiha, Tharif, and Shaviz. I'd also like to know your answer. Correct. थोड़ा सा गलत है बस. I mean closed interval and open interval. It should not be open interval at the first point. It should be closed interval at the first point. Infinity is always open interval. That is correct. Good. And did you understand why, Madhya? We will discuss that while solving the question. But
Sorry, sir. I have confusion in that at that.
I mean, this will give answer 0 also. No? If I put x as 1 or minus 1, in that case, the value of fx would be 0.
Oh, okay. Yeah.
Range
Yes.
should be equal to 0.
Correct, yes.
Okay, so we got the correct answer. So we will proceed after this. And whoever was trying and not able to get it, let's solve this. So here it's given that fx is equal to root over x square minus 1, where x can take these values, right? So we have discussed one method like that the method or the procedure to find out range, but also I have told you to understand the range perspective with analytics. Like you can give or you can put the values of x here, and you know what are the values of x that you can put, and think about how the range or how the output is affecting by changing the values of x. So let's say if let's take all of the positive values of x first, just ignore negative values, because see, there are two reasons to say this. Because one is that all the negative values of x would also give you the same answer as the positive values of x, because we are using x square. We are not using x, just x. In the expression, we have x square. So x square will produce the same result as negative and positive. I mean, for both negative numbers and positive numbers. And one more reason to say this is that let's take first set now only. I mean, let's take one set only. We can't anyway check both of them simultaneously. So let's take either negative values or positive values, and then we can also go for another type of values, right? So I'm taking, for simplicity, I'm taking positive values first. So positive values first, money, I can take anything. Sad, just one question. Where are you from?
Hyderabad, sir.
Hyderabad. Okay. Do you understand Hindi?
Yeah.
Okay, cool. No, I mean class तो वैसे English में ही चलती है, but sometimes when I कुछ बच्चों के लिए मेरे को लगता है कि हिंदी में ज्यादा अच्छे से समझा पाते हैं, और कुछ चीजें भी ऐसी होती हैं जहाँ पे हमें लगता है कि शायद मेरे को हिंदी यूज करूंगा तो बेटर लगेगा. That is why I was asking.
Okay, sir.
Okay, so here we can put any value from 1 to infinity. Let's check by analytics only first. So if I give it 1, then x square is also 1, and the whole value becomes 0, right? And now if I increase the x from 1 to 2, then the value will be root 3. In case of x3, the value will be root 8. So the value is increasing. See? And as I increase the x, the output will also increase. So I can simply say, okay, the output seems like it is taking all the positive values, 0 to infinity. Okay? This is my first guess, which is an educated guess, not a random guess. But we were trying to solve this using the values of x. And in that case, we figured that the value should be, or the answer should be, from 0 to infinity, right? Which is also correct when you solve the question through your method. Now let's solve the question through how we have learned this to solve. So replace fx first with y. Now in the starting, I have given y in terms of x. What I would do is I would try to change this as x in terms of y. For that, I will square both sides first. So this becomes y square is equals to x square minus 1. I would take minus 1 to the side of y square. So this becomes x square is equals to y square plus 1. First, I took minus 1 to the left hand side, and then I just changed both of sides. If I'm writing LHS as RHS and RHS as LHS, then the equation is also same. X is equals to 4 or 4 is equals to x. Both are same thing. You can write it in either way, right? That is what I've done. First, I took minus 1 to the left hand side. So it becomes y square plus 1 is equals to x square. And then I have written x square is equals to y square plus 1 because I want to find out x in terms of y, right? So I can remove square. After removing square, I will put plus minus to the right hand side, and I can write the expression like this. Now the second step is completed, that I have got x in terms of y. After getting x in terms of y, I would find out the domain of this function, which will be the range of original function, right? So to find out the domain of this function, we know we have two conditions. First is expression inside the root, which is this in case y square plus 1. Expression inside the root must be positive, right? And the second condition should be that if there is a denominator, that denominator should not take value 0, or that denominator should not be equal to 0. But since there is no denominator involved in this case, so we will have only one condition, which is y square plus 1 should be greater than equal to 0. Now, if you think carefully, this is always greater than equal to 0 because y square is also a positive quantity and we are adding 1 to that. So positive quantity plus 1 will always be positive. Or another way to think is that you can solve this inequality. So if you solve this inequality, you get y square greater than equal to minus 1, which is true in every case. If you see, which is true for all y, you take anything and square it, that square will always be greater than equal to minus 1 because square is a positive quantity, right? So from here, you can take y any real number. But since you know that y is a result of the square root, so y will only take non-negative values. So the answer must be 0 to infinity. Y can take any value, any positive value, or rather non-negative value. Right? So that is how we can find out the range of a given expression or a function. And there are many other ways also to find out the range. But this method is like the first method we should hang on to, or we should go to while finding out the range. Right. Now we have covered two things in the last two classes. One is to find out the domain, and second is to find out the range of a given function. Right. Now let's come to the question part. How will we have a question based on this domain and range, or rather many one and onto into functions? So we'll be given a function, and after giving that function, they will also provide you with the domain and codomain of the function. So it will be written like this. For example, let's solve a question only. Let's take this question. Okay. Y is equals to fx is equals to root. I mean, fx is equals to root over x square minus 1. So what they would do is, if they will frame the question, they'll frame it like this. They'll ask you, consider a function f such that fx is equals to root over x square minus 1, and f is a function which is defined from minus infinity to minus 1 union 1 to infinity to real numbers. Now understand this sentence first, what they are trying to show us or what they are giving us. This is very important to extract the information from the question. Then only you'll be able to process that information. So the information given in this part is, first they have given you the expression of the function, and then they have given you the domain and codomain of the function. So this is the expression of the function. This part will always represent the expression in which your fx will be given in terms of x. And then f will be defined from such to such. This is such that we read it as such that. So f is defined such that minus infinity to minus 1 union 1 to infinity. So this is basically your domain of the f. That is, these are the inputs that you can provide to x. And this is your codomain. Domain and codomain. So they have provided you the input of the function. They have provided you the possible outputs. Remember, codomain was the possible outputs. So they have provided you with the inputs of the function and possible outputs of the function. And now they are asking you, find out.
Sir,
Yes.
what is the meaning of arrow here?
R is real numbers.
No, like arrow.
Acha, arrow is defined. This is read as defined from 2. So f is a function defined from minus infinity to minus 1 union 1 to infinity. And this arrow is like 2 or function. You can also write it like this. Okay, there is another representation of the same thing. Sometimes it can also be written like this. So this arrow is basically representing from 2. From and to. This says that f is a function defined from this to this. So defined from mane domain. That is the set of inputs that you can provide to the function. And defined to mane, what are the possible outputs? So basically we are mapping these two sets right now according to the condition root over x square minus 1. This is what actually the meaning of this whole expression. Did you understand it, Charles?
Yes, sir.
Okay. So, and this R is real numbers, obviously. Yeah. Okay. So they'll ask you, find out whether f is many 1/1 and onto/into. Or they can frame it like prove that f is many 1 and onto, or maybe into, whatever the type of function f is, they can tell you to prove that. Both the questions are same only. They want you to find out whether the function is many 1 or 1 and again then onto or into, right? So what we can do is we can solve it in 2 ways. First way is to go through the procedure which we have learned. We know how to find out many 1 and 1, and we also know how to find out onto and into. So let's start it with that only. So if I find out f is 1 or many 1, I mean, if I want to find out whether f is many 1 or 1, what I would do is consider I will take two values from its domain. So I will take x1 and x2 from the domain. Now the domain is a bigger domain is a bigger set. So in spite of writing the whole interval, I'm just writing it like this. Consider x1 comma x2 belongs to domain of f. That is minus infinity to minus 1 and union 1 to infinity. So there are two values x1 and x2 which belongs to this whole interval, right? Now what I'm doing is I will assume that fx1 and fx2 both are same. or if I want to interpret this, this is like, this is, I mean, this expression is saying that the output at x1 and the output at x2 both are same. And I have assumed this. I don't know whether this is true or not. How would I know? I would solve the expression fx1 is equals to fx2. So fx1 would be root over, because they have provided me the expression already. So what I would do is I would put x1 in place of x in that expression. This becomes fx1 is equals to root over x1 square minus 1. And then fx2 would become x2 square minus 1. I will solve this question. I mean, I'll solve this equation. And after solving this equation, if I get only one answer, which is x1 is equals to x2, then the function will be 1, 1. And if I get two answers and both of them are valid, then I'll say that this function is many 1. So let's solve this. Squaring both sides, this becomes x1 square minus 1 is equals to x2 square minus 1. This minus 1 gets cancelled out. So we are left with x1 square is equals to x2 square. I can also write it like this, which can further be factorized using a square minus b square formula, which is a minus b into a plus b. Right? Now, if I take the first factor, which is x1 minus x2 is equals to 0. So that gives us x1 is equals to x2. Okay, we got one answer. If this is the only answer of the expression, then we will say the function is 1, 1. But we also got another factor, which is x1 plus x2 is equals to 0, which gives us the answer x1 is equals to minus x2. Right? So we got two answers first of all. Now what I would do is I would check whether the second answer is valid or not. Do you remember how to check? Can anyone point this out? How to check this, whether the second solution is valid or not? Okay, take any value of x2 from the domain. Now you know the domain. What is the domain? Minus infinity to minus 1 union 1 to infinity. So take any value of x2 from that domain. Let's say I have chosen 1. Okay. So if x2 is 1, what is the value of x1 according to the second condition? X1 is minus 1 in that case, right? So minus 1, you will check whether minus 1 is valid or not. Is minus 1 in the domain? Yes. So that is why the answer is valid. The solution is valid. Second solution is also valid. So that is how we check whether I mean, we may have more solutions also. Let's say one solution could have been this x1 is equals to x2 plus 1. So what I would do, I would take values. I would check whether the given solution given solution exists or not. For example, if this would have been a solution, then this does not exist. How? I will take values. So I will take x2 as 1. I will take x2 as 1. So if I take x2 as 1, then x1 is 2. Is x1 2 valid? Yes. Now let's take x2 minus 1. If I take x2 as minus 1, then x1 is 0. And at x2 is equals to minus 1, first of all, write this. At x2 is equals to minus 1, x1 is equals to 0. Right? Now x1 cannot take value 0 because 0 is not in the domain. Right? So this is not valid for this. But what do we need? We need only one solution, man. If there is a single point at which this solution is valid, then the given solution is valid. So if I take x2 as 1, then x1 is 2, which is perfectly valid, which says that this solution exists, and which also says that the given function is many 1. So there may be some cases where your solution exists for some values but don't exist for some values. In that case, what do? We just want to find out one case where the solution exists. If the solution exists at one case, then the solution valid. The given solution is valid. Right? But thankfully, we don't have this condition here. So we don't need to check that much. But to check the validity, you have to follow these steps. Take any value from the domain for the value of x2, and then check whether the given value of x1 is present in the domain or not. If this process is true, even for a single data point, then your solution exists. Now, in this case, you put x2 as 1, you get x1 as -1, which is perfectly valid. Hence, both of the solution exist. And if both solution exist, we say the given function is many-one. Also, if the solution is valid, you don't need to show it. But if the solution is not valid, then you will tell this, that the given solution, let's say in this case, the given domain is this. Okay, let's just change the question for once. I want to show you something. So let's say the given function is like this. That function f is defined from 1 to infinity to r, all real numbers. It means that the domain is 1 to infinity. Now, if I say put x2 as 1, then you get x1 as -1. -1 is not present in the domain. In that case, I would tell this. How would I show it? I would like to show it like this. Put x2 as 1, then x1 is equals to -1. And you know, it will not exist for any case. Because if you take x2 any positive number, x1 will always be negative, which is not valid. And you can only take x2 positive number because the domain is 1 to infinity. The given domain is 1 to infinity. So you can only take the positive values. And as soon as you give x2 a positive value, x1 becomes negative, which is not present in the given domain. So I can say that if x2 is 1, then x1 is equals to -1. Solution is not valid. If the solution is not valid, we only have one solution. This x1 is equals to x2. And we will say that the given function is 1, 1. But in this case, oh, I have written it incorrectly. But in this case, as the solution exists, so we don't need to show it that the solution exists. But yeah, we need to check it for ourselves. I mean, whether the given solution is true or not, you will have to check. Then only you can answer this one. So you should know how to check this, how to check the validity of the solution. So x1 is equals to minus x2 is also a solution. So as we have two solutions in this case, hence the given function is many-one. So this was the test for many-one and one-one. And now similarly, we can check onto and into. You have already find out the range of this function. You know, range. This is the second part. This was the first part. To check onto into is the first part, and to check many-one, one-one is the first part, and to check onto and into is the second part. As we have already find out the range, we know the range is 0 to infinity for this given function. Now we know range is 0 to infinity, and codomain is already given. So we know range is a subset of codomain. Range is not equal to codomain. Or we can write it like this. Range is a subset of codomain. Hence the given function is into. This is how a question can be given to you. Let me complete this also. So this was minus infinity to -1. Union 1 to infinity. Anji, please feel free to ask your doubts. Yeah, Austin. So for into, so we know, first of all, before that, do you know, right, how to find out range now?
Yes.
Okay. So as soon as we got the range, right? So in this case, the range is 0 to infinity and the codomain is all real numbers. If the range is not equal to codomain, which means, I mean, range will always be a subset of codomain. See, range is the answers we got, and codomain, the whole answer set we could have got, right? So range will always be a subset of codomain only. I mean, there won't be a single value which is in range but not in codomain. That can't be possible because I mean, the answers we get will be from the set of possible outputs only, right? So we would like to check whether the range covers the whole codomain or not. For example, in this case, codomain is your all real numbers, but range is only 0 to infinity, right? So range is a proper subset of codomain. Range is not equal to codomain. Codomain also consists the negative number set, right? But range is not including that negative part. So that is why what I'm saying is that range is a proper subset of codomain. So there is a small difference between proper subset and subset. I have been using this word proper subset, I think from the last class, but I have not told you guys what is the meaning of proper subset. You can understand it from this. Let's say a set A is given 1, 2, 3, and set B is given as 1, 2, right? So we can say that B is a subset of A, right? So B right now is a proper subset of A. Now, why I'm using proper subset term, we will understand it. Let's say B set is also 1, 2, 3. Abhi I can say that A is a subset of B or B is a subset of A, but also they are equal. Right? So whenever the sets are equal, we call them as equal set rather than subset. They can be called as a subset of each other, but rather than calling them subset of each other, what we do is we call them as equal set. That is a more accurate term for this. But if B is not 1, 2, 3, and let's say B is only 1, 2, in that case, B is a proper subset of A. So proper subset means that B is not equal to A. It's a proper subset of A. That, I mean, if you're saying that B is a proper subset of A, I will say that B contains the element which are present in A, but A has more elements than B. Did you understand it? What is this proper subset and what is just subset? So, okay, I'll try to explain it in another way as well. So let's say I'm writing the whole subsets of B. B is a set containing two elements, 1, 2. I'm writing the subsets of B. So 5 is a subset of B. Then 1 is also a subset of B. 2 is also a subset of B. And 1, 2 is also a subset of B. We have learned this in class 11 that how to find subsets of a set, and the formula was 2 to the power n. So let's say a set contain n elements, then the total subsets of that set will be 2 to the power n. Right now B has 2 elements, so the total subset should be 2 to the power 2, which is 4. So these 4 are subsets of B, but these 3 are proper subsets, and this is an equal set. So when the set is smaller, we call it, I mean, when a subset is smaller than the set, then we call it as proper subset. And 1, 2 is also a subset, but rather than calling it a subset, we will call it as equal set. So did you understand the meaning of proper subset?
Yes.
Okay. So now come to the second part again. So range here is 0 to infinity, which is positive, all the positive values. And codomain is all real numbers. So in this case, range is a proper subset of codomain because range is smaller than codomain. Codomain contains more values than range. Codomain also contains all the values which range has, which should be the case also. But codomain also has other values which range doesn't have. So we can say that range is a proper subset of codomain, and that is why it is into function. Now let's say I convert this function, or I convert this codomain like this. So if I say in the question part itself, I change this R, and instead of R, if I have written 0 to infinity, Now you check. Range is also 0 to infinity. Codomain given is also 0 to infinity. Then I would say that range is equal to codomain. I would use the sign of equality rather than proper subset. And I would say that the given function is onto function. Did you understand?
Yes.
Okay. Guys, anyone, you are free to reach out and ask whatever you want to. As far as we're concerned about the concept is over for the chapter. This is the last concept that how to find out onto and into. Just let me check once what is the syllabus. Although we have checked, I guess, but yeah, one-to-one and onto functions only. Correct. So we don't have. We had things. I mean, we had more topics earlier, but I think they have removed invertible and invertible function and all these things. Binary operations also. So we know how to find out many one. We know how to find out onto and into functions. Now we will use these concepts in understanding whether a given function is many one or onto and into, whatever that is. So let's try with some questions. And before that, please feel free to ask. Take your time, write down. And I would give you 1 minute to understand all of this. And you can come up with your questions if you have any. Otherwise, we will start with the questions. But just first of all, absorb this, what we are doing, how the structure would be. We will be given a function with the expression of the function and domain and codomain of the function. And they will ask us about the many one nature and onto into nature of that function. This is the whole question which we are going to get. Okay, we can proceed. No questions? Sure, cool then. Solve these questions, you will then have doubts and then you can cover them up. So, okay, so you have to comment money, you have to basically find out. Okay, comment on many one and onto into nature of the given functions. The first function is okay, let's start with some easy ones. So f is defined from real numbers to real numbers. That is, domain is also real number and codomain is also real number. You have to find out whether the given function is many-one, one-one or onto into. I mean, many-one or one-one and onto or into. Solve this first part. Everyone, please start solving this. This is a question you will be getting in your CBSE boards for 4 marks. I mean, this is sure. We already know what is going to be asked in the paper. I mean, we don't know the questions, but we know the pattern. I mean, if you would take last 10 years or 15 years or 20 years paper, you can also identify this pattern. What are they going to ask and what did they ask before, when the whole syllabus was given, and what will be they asking this time. This is the only topic you have in function. So you will be definitely getting a 4 marks question on many-one, one-one and onto into nature of the function. This is sure. Just like this is sure that you will be getting a question on matrix method in matrices and determinants. That is also sure. You'll be getting a 4 marks question for solving the linear equations, linear system of equations. So start solving this. If you are stuck in at some point, I'm there. I'll help you out. And for Saad, these questions start with a predefined strategy. We don't have to do much, though we have discussed all the technical details. But if you want to just check for many-one and one-one, you will always have to start from fx1 is equals to fx2. So for checking out many-one, one-one, solve the given function for fx1 is equals to fx2. Find out whether there is only one answer or there are more than one answers of that equation. And for the onto into part, you have to understand first how to find out range. वो अभी नहीं होगा, but many-one, one-one हो सकता है. First, put the heading for many-one, one-one. Solve it. Always start it like this. You know, the first 3 lines are always going to be same. ठीक है, पहले solve कर लो. I mean, first solve this. Then I would also like to share one more thing. शायद correct है. Good. Austin, it's correct. Good. हाँ जी, 1-1 भी होगा, many-one भी, I mean 1-1 भी होगा और onto भी होगा. Simple है. fx1 is equals to fx2 को solve करेंगे. So this comes as x1 plus 1 is equals to x2 plus 1. After solving, there is only one answer. 1 gets cancelled out on both sides. So x1 is equals to x2. Right? There is only one answer. And that one answer tells you that the given function is 1-1. If there would have been more than one answers, like in the first case, then we would have said, first we would have checked for the validity of the solution. And if the solution is valid, then we would have said that the given function is many-one, right? Yeah, Shavis. Now, if I come to second part for into onto, what I would do is I would replace fx with y first. and then I would find out x in terms of y. So x in terms of y is x is equals to y minus 1, right? Now I will find out the domain of this function. You can check. There are two conditions involved with the domain. First is square root, but there is no square root involved in this expression, so not a condition. And then second condition is denominator. Denominator should not be equal to 0, but since there is no denominator, so we don't have to apply any condition, which means that y can take any value. There is no restriction on y, right? If there is no restriction on y, it means that y can be any real number, which means that your range can be any real number. Now range is all real numbers, codomain is also all real numbers. So you can say that range and codomain are equal. And if this is true, then the given function is onto. Right? Means the function is 1, 1 and onto. Okay. Faiza, first you tell me. Did you understand this? How we are solving 1 for many 1, 1, 1 and onto into? And if not, then please tell me if there is a problem with this, then please ask me. And same goes for Humamuddin, Madiha, Tharif, and Shavis. Okay. And what about Humamuddin? Did you understand this?
Yes, sir.
And this question goes for all of you. Madiha, Tharif, Shavis.
Yes, sir.
क्या कहना है? समझ आई ये बात कि नहीं?
Yes.
यार अगर नहीं आएगी कहीं से बात समझ तो पूछना पड़ेगा. If you want ask तो मुश्किल होगा मेरे को पता करना कि ओके ठीक है चलो. Then increase the difficulty level of the questions. तो कुछ ही question, only few questions are important or tough, rather I should say, not important. चलो ठीक है. Let's check this. F is defined from 0 to infinity to real numbers. So domain is your 0 to infinity and codomain is all real numbers. The given expression is fx is equals to root x. We have to check for this. You first solve second part, okay? Anji, anyone? What about many one, one? Let's start with one objective at a time. Is it many one or one?
So is it on one?
One, correct. And what about onto and into? So to start from here, this goes like root over x1 is equals to root over x2. Right? And you can square both sides now. So it gives you x1 is equals to x2. There is only one answer to the question. And the function is 1. Now let's come to the second part for onto and into. So for onto and into, first replace fx with y. So your y is equals to root x. Now y is given in terms of x. First find out x in terms of y. So square both sides. This gives you x is equals to y square. Now you have to find out the domain of this. You know two conditions are there. So can you tell me the range after this point? What is the range for y?
Sir, is it onto?
Sorry, first of all, is it
Onto?
all real numbers? Onto, acha, yeah. Okay, no, this is not onto. This is into. पर उससे पहले ना शाविज, ये छोड़ अभी onto into. Before that, we need to identify what is the range of this function. अगर हम range सही निकाल रहे हैं, if we are finding out the range correctly, तो आंसर तो करेक्ट होना ही है यार, वो तो कोई बात ही नहीं. तो अभी तो कोई condition. Now, what should be the condition we? I mean, what is the condition that we should apply? Do we have a condition here?
No.
No, right? There are two conditions. First is for square root and second is for denominator. But since there are, I mean, both of them are not present in this case. So we can say directly that there is no restriction on y and y can take all real values. Now just go back once. What is y? Y is root x, right? So whatever be the value of y, that should be positive. No, because y is an output
Yes,
for
sir.
root. Yeah. So we will tell it. बता देंगे भाई यहीं पे कि भाई y का आंसर ही आ रहा है स्क्वायर रूट से. Since y is an output, of square root, which is a positive number, so y cannot take any negative value, means y belongs to 0 to infinity, right? Which means that your range is 0 to infinity. Now you know your range and you know your codomain. Codomain is all real numbers. You can check that range is a proper subset of codomain. Codomain is a much bigger set than range. And hence we can say that the given function is into. हाँ जी, समझ आई ये बात? Did everybody understand this? या देखो, या तो you will have to ask if you are not able to solve anything, then please share it with me. It's okay. 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 I want to discuss one more thing before we proceed to third question. Okay, let's come to the second part. Okay. Sorry. Let's come to this question. Now here the function was many one. See, we have solved it and the function was many one. So in case of these many one functions, what we can do is we do have one more approach, or we can say that we have a short method to solve this. If you are able to provide two values where the output is same, how do we find out the function is 1, 1 or many one? We check for the outputs. No, we will use different values for x, and we will check whether there are any two inputs which are producing the same output. For example, in this case, if you find out f1, what is f1? F1 is 0. You put 1 in place of x and you get f1 as 0. Now you find out f minus 1. F minus 1 is also 0. So what you can do is, when the functions are many one, you can directly use these two values to demonstrate that. So you will directly say that f1 is equals to f minus 1. Hence the function is many one. Just show for one case. Show them one case where the function is turning out to be many one. And you can directly say that as f1 is equals to f minus 1, hence the given function is many one, because both are producing the same output. Right? So this was one thing which I wanted to share, that when the functions are, now the problem is, how do we find out whether the given function is 1, 1 or many one? Either we know directly. Just if you see, there is x square involved. So we know x square will produce the same result for positive as well as negative values. So if I take f2 and f minus 2, they will also give us the same result. f3, f minus 3, same. Whatever the answer is, but answer will be same. So either you can identify the given function like this, whether a square is involved with x or not. If there are functions like this, then you can definitely say that, then you can definitely take two values and show it in a short way. The given function is many one. But if not, if you're not able to find out those two values shortly, within 30 seconds, then you will solve it like this, with this method you have been described. All right. Okay. But I would suggest you guys to solve it. Solve this with the proper approach only, because sometimes you won't be able to get whether the function is 1, 1 or many one. And when that happens, you took a lot of time to figure out that we should have solved this in the proper approach. So take proper approach and solve it for many one, 1, 1. And this is mod here. This is modulus. And we know what is the job of modulus: to make everything positive. Right? So first you solve it for many one and 1, 1. Then we will discuss about onto and into. But first you guys solve it for 1, 1 and many one. Try this. This is a harder one, but let's try this. Anji, what's the answer? Okay, let's start for many one and one. So consider two values. So to solve this mod x, you can take two cases. You must know how to define mod for this, and we have discussed modulus in 11th class. So let's come to that part again. So mod x can be defined like x or minus x, depending on x is positive or x is negative. So if x is negative, this is basically the functioning of mod x. So what does mod do is, so let's say you take mod 4, the answer is 4, right? But if you take mod of minus 4, then also answer is 4. So how is this happening? With this rule, which we have described here. So if there is a positive quantity inside the mod, if there is a positive quantity, x is greater than equal to 0 means that if x is a positive quantity, right, then you take out the same x as it is. So if x is a positive quantity, like in this case, 4 is a positive quantity, then you take 4 as it is outside, right? But if x is a negative quantity, x is less than 0, then while removing modulus or while removing these bars, you put a negative sign before that. So actually this minus 4 becomes 4 like this. So what modulus, first of all, we gave this minus 4 as an input to this modulus. So it realized that the given value is negative. So what it would do is, when we will remove these bars, it will place a negative sign outside minus 4 because it wants to make it positive. So this is the logic we can apply while solving the questions of modulus. Okay, how do we apply this? So let's start with the solution now. This was just a small demonstration about modulus, and the graph of modulus is like this, V shape. This is in V shape. This is y is equals to x, and this is y is equals to minus x. This is modulus function. So just a minute. Yeah. So what we would do is we would first solve it for many one and one. We know the methodology. We will take 2 points from the domain. Or basically we can say that real numbers, and let fx1 is equals to fx2, right? Now you can also break this function into 2 parts. You can say that the value of fx is x upon 1 plus x when x is greater than equal to 0. So I'm basically opening this mod x. I can write mod x as what? Plus x or minus x. depending upon the value of x. So I could have done this also. In that case, there are 4 parts now for solving many one and one. How? One is when both of x1 and x2 are positive, right? Then second is if x1 is positive and x2 is negative. Third is x1 negative, x2 positive. So what we will do is we will first consider x1, x2 both are greater than equal to 0. Then we will take x1 is greater than equal to 0, but x2 is less than 0. Then we will take x1 is less than 0 and x2 is greater than equal to 0. So both positive, one positive, one negative, there will be 2 cases and both negative. X1 as well as x2 less than 0. Why did we do this? Because the function is defined differently for positive and negative values. The given function is defined differently for positive and negative values because there is a modulus x involved in the function. So we will divide this into 2 parts. First, for x greater than equal to 0, the function is x upon 1 plus x. And for x less than 0, the function is x upon 1 minus x. Right? So we will take one case each at a time and we will try to solve this. So when x1 and x2 both are greater than 0, then your fx1 and fx2 will look like this. Oh, sorry, my bad. Not implies that. We would like to write since fx1 is equals to fx2. Now, while writing fx1 and fx2, you will focus what is the value of x1 and x2. In this case, both of x1 and x2 are positive. So I would write fx1 using this formula. Because when the input is positive, the expression for the function is x upon 1 plus x. While when the input is negative, the expression is this. So in the first case, both the inputs are positive. So I can write it like this. x1 upon 1 plus x1 is equals to x2 upon 1 plus x2. Now, and we will be able to solve this. You can solve this later on and try to find out the answer. Okay, we will solve it. But before that, now here also, let's define this function also. We know we have to apply fx1 is equals to fx2 in all the cases. But fx1 and fx2 can change. How? In this situation, x1 is positive, but x2 is negative. So if x1 is positive, fx1 will be defined as this. But since x2 is negative, so fx2 will be defined using this formula, which would be x2 divided by 1 minus x2. Did you understand this transformation? This is important. Without this, we will not be able to solve the question. Now, can you write the expression? If you understood this, can you write the same expression for this case? Third one, x1 less than 0 and x2 greater than equal to 0. How should we write the equation? Now, x1 is negative. So we will choose that equation which represents the expression for negative values. We have 2 expressions. This one is the one which represents for negative values. So how would we write is fx1 in this case would become x1 upon 1 minus x1 is equals to x2 upon 1 plus x2. No, fx2 will be defined according to this condition and fx1 will be defined according to this condition. We know what is fx. Now, when both of these x1 and x2 are negative, the expression used will be this for both the cases. So fx1 is equals to fx2 will be written as x1 upon 1 minus x1 is equals to x2 upon 1 minus x2. We will solve all of these cases. We will find out whether the solution is valid or not. So let's solve first case first. So this becomes cross multiply. So this becomes x1 plus x1 x2 is equals to x2 plus x1 x2. So I have cross multiplied them. This becomes x1 into 1 plus x2, which is x1 plus x1 x2, and this becomes 1 plus x1 into x2, which becomes x2 plus x1 x2. This gets cancelled out. So the only answer is x1 is equals to x2, which is valid, obviously. We don't check this for the validity part. We have discussed this in the previous process. Okay, now this is the second part. So this becomes x1 minus x1 x2 is equals to x2 plus x1 x2. So this is your x1 is equals to x2 plus 2x1 x2. x1 is equals to x2 plus 2x1 into x2. What do? You take any value for x2. I mean, I would check now the validity. So I would take any value of x2. Now I know what can be the values of x2. x2 can only take negative values this time because we have already defined that, right? So x2, take x2 as a negative value, let's say -1. Okay, now I will find out what is the value of x1. So x1 is equals to -1, and this becomes -2x1, right? Because x1 is -1, so this becomes -2x1. -2x1 can be taken out to the LHS. This becomes 3x1, and x1 here gives you -1/3. x1 here gives you -1/3. Now you think about it for a second. Just think about it. x2 can only take negative values. You put x2 negative, this is negative. See, this is negative. If x2 is negative, this term is negative. And if x2 is negative, this term is also negative, second term. When you take second term to the LHS, this becomes positive, right? So this whole term will always be positive in the left hand side, and the right hand side will contain this x2, which is negative. So answer of x1 will always be a negative, which is not possible in this case. Not possible. Why? Because we have already defined that x1 is positive. Then only this case is valid, right? So if we give x2 some value, x1 will not be valid because x1 will always come out as a negative number. And I have just told you the logic of it, that if x2 is negative, this is negative. This is also negative. You take this to the right, I mean left hand side, this becomes positive. The whole of these, I mean both of these two terms are positive. This is positive and this is also positive when it comes to LHS. And they both positive. I mean a positive term is equals to negative term, then the value of this variable will always be a negative. Hence this solution is not valid in this case. So we only have one solution, right? Now let's come to this part. This also becomes x1 plus x1 x2 is equals to x2 minus x1 x2. If you solve this, now you know x1 is negative and x2 is positive. So if you use the same logic as you did in second part, so you can take any value of x2. Let's take x2 some positive number. I mean, we can only take this as a positive number. So take x2 as 1. Now guys, you will be having an assessment test, so please stay. Whoever has attempted, 3 of you has attempted it in the last class, but all of the remaining person, please stay in the class and check for the, I mean, give that assessment test. Okay, so take x2 as some positive value. Let's say we are taking x2 as 1. Then x1 plus 2x1 is equals to 1, right? x2 will be positive, so this will be positive. This will be positive. We don't know about this. We have to find out x1, right? So if this is positive, This is positive. They both make a positive term is equals to a positive term. Right? As you can see here, a positive is equals to positive. So what is the value of x1? 1/3, positive. But x1 was negative in this case. So this is not possible. Hence, this solution is also not valid. Now let's come to the fourth part. They gets cancelled out. There is only one answer. X1 is equals to x2. There were 4 cases, but see, we only get 2 answers. And both of the answers are same. So after solving all of these cases, we can say the above calculations x1 is equals to x2 is the only solution. And hence, the given function is 1. And similarly, we can check for onto and into as well. I think we don't have much time today, so we will cover this onto into part in the next class as soon as we start the class. And you guys also try this at home, whether you are able to solve it or not. And then we'll be discussing this in the next class. And before that, just give me a minute. I'll also tell you what is the homework for this week. So you will have to cover an exercise of NCERT